Photocatalytic oxidation, or PCO for short, was originally developed by a team of NASA and MIT engineers. They wanted to come up with a technology that could address viruses and pathogens in the air and on surfaces for the space program. The first generation consisted of a UV bulb, which acted as a photon emitter, surrounded by a titanium dioxide screen. So the premise was when the photons would strike the screen, coated in titanium dioxide, positive hydrogen ions and negative oxygen ions would be produced. So once you had the hydrogen, positive hydrogen, negative oxygen ions produced, they would attract to each other and form a bipolar ion cluster. This ion cluster, once it's propelled into the room, in this case, for example, say the space shuttle hatch or the International Space Station, the living quarters or the lab, it would address or attack any virus or pathogen in the air and surface. Well, this was effective for the zero gravity lab in the International Space Station, where they wanted a clean environment to conduct their studies, or the hydroponic plant growing project, because these ion clusters were effective in addressing plant pathogens. By the mid-1990s to late 1990s, it was implemented in the space station, International Space Station, the space shuttle missions. And I got involved with the group in 2003, where we took NASA's original design, and primarily Mr. Tutman and myself, after approximately eight and a half years of research, and were able to improve NASA and MIT's design quite substantially. What we have now is the current product, photocatalytic oxidation, which is patented in the United States and internationally. But what we're able to do is use a 254 nanometer UVX wavelength probe, which is a photon emitter, and we use 6 rare earth metals that's on the coating. So we're able to amplify the number of ion, positive hydrogen ion, negative oxygen ion clusters that we produce measured per cubic centimeter, which I illustrate, it's like the old sugar cubes that we used to use.